All right, so you've probably dealt with polar coordinates, or you should have. It's prerequisite for dealing with this material. And if you remember from polar coordinates, we can represent any location as with like a distance to the point and an angle, right? So any point can be represented with r theta. So if you think about it, what you actually have is you have theta tells you the direction that you go in, and r tells you the length or the magnitude that it takes to get there. So it's natural that vectors are related to this polar coordinate representation, right? Because you have a magnitude and a direction. So if we think about this idea that there's this r cosine theta and r sine theta, and those are your x and y components respectively, and r is really just a magnitude, then in the case of a vector, we don't use r, we use the magnitude of the vector v. So that tells me that instead of r sine theta and r cosine theta, we can use the magnitudes here. So by knowing that, we can then take and form a vector using angles and magnitudes. So if we have a vector v with components v1 and v2, and it forms an angle theta between v and the x-axis, then we can use this format to be able to completely define that vector. Well, why is that important? Well, because often we do have magnitudes and directions. So think like headings for a plane, right? You know how far off you're going, and you know how far you want to go. Or in things like when you deal with missile dynamics, let's say I'm trying to fire I've got something coming at me. I'm trying to fire an anti-air missile, trying to stop it. Well, I usually think of things in terms of azimuth and elevation and range. So I know that's 3 dimensions, and we'll get there. But the idea is that you think of things in terms of an angle, and a length. So it's natural to be defining things in these coordinate systems as opposed to defining them in the standard Cartesian coordinate system. So what we find is this. Now, if v is a unit vector, it's even nicer. So if we call u the unit vector in the direction of v, then we can just drop the magnitude section. So what that allows us to do is you can really think of unit vectors being defined in terms of a single variable. It's only defined in terms of theta because we have a constrained variable. So you really don't have a 2D system anymore. You just have a one-dimensional system. And the only dimension that's varying is the angle. That's going to be really, really helpful down the road. If you guys go into doing anything that has to do with just physical dynamics of systems and things like that, one-dimensional or being able to reduce the dimensions really rates performance increase. You can do a lot of really neat things. There's this really cool concept called a quaternion that allows to go from a 4D to a 3D. It's used in computer graphics. It's used in all kinds of stuff anyway, that's extra for you, but this is the idea of the relationship to polar coordinates.